Is climate change the same on the whole planet?
Definitely not. We observe much more intense changes in the northern hemisphere. The biggest changes in air temperature are observed in the Arctic, and for some parts of the Arctic, the changes are even 6 times higher than the average temperature change for the globe. On the other pole, in the Antarctica, the average temperature is only slightly changing. The changes on the equator are also much smaller than in our latitudes or in the Arctic.
Why is the Arctic warming so fast?
We call this phenomenon Arctic amplification. It's the fact that temperature rise in polar regions is large in comparison to the temperature rise in lower latitudes and may further accelerate climate warming well beyond the Arctic. The warming trend in the Arctic is at least twice as large as the global average in recent decades, and in some parts of the Arctic, for instance in Spitsbergen, it's up to 6 times higher. There are several reasons for that. The most important one is connected with the decreasing sea ice extent. We have been observing and measuring sea ice extent in the Arctic since 1978, when the satellite observations started. Sea ice extent changes spectacularly during summer. The average sea ice extent in the satellite records in summer is 6.3 million square kilometers, whereas during the last 20 years we lost almost 1/3 of the summer sea ice.
How does this affect climate change?
It's connected with albedo, the amount of sun radiation reflected back by the surface. Ice and snow have high albedo. They reflect a lot of sunlight, even 90%, whereas dark ocean, not covered by ice, absorbs a lot of sun radiation. The higher air temperature, the faster sea ice is melting and uncovers dark ocean, which absorbs more sunlight. It increases water temperature and consequently air temperature, and further accelerates the process of melting sea ice. Therefore, we call it a positive feedback loop. It enhances and amplifies the changes.
Are there other feedback loops affecting the Arctic climate?
Another example of the positive feedback loop in the Arctic is also connected with sea ice. During winter, air is cooler than water and ice acts as an isolation layer. However, when the sea ice cover melts, heat escapes from the ocean to the atmosphere and causes the rise of air temperature. There is also an example of negative feedback loop, which slows down changes and helps the system return to balance. Higher air temperature increases evaporation, which leads to formation of more clouds. Clouds protect the ground from sun radiation, but this effect works only during summer months. In winter, clouds act as an insulation layer and keep warmth close to the ground.
What other changes are present in the Arctic?
Another important factor connected with the climate change is permafrost thaw. Permafrost is permanently frozen ground. It's soil, rock, and organic material that remains at 0 degrees Celsius or below for at least 2 consecutive years. It contains organic matter that didn't decay previously because of the cold. Due to climate change, permafrost is thawing much faster, and organic matter thaws, microbes degrade it, and in the process, carbon dioxide and methane are released. They are greenhouse gases, and their release further accelerates the climate change. Reduced snow cover on land affects boreal forests. They become more susceptible to drought and consequently to fire. The ecosystem needs circa 100 years to get back to the state before fire. Fires cause additional emissions of CO2 to the atmosphere, and this is another example of positive feedback loop.
The Arctic is far away from our homes. Should we, here in Europe, bother about what happens in the Arctic?
Unfortunately, yes. What happens in the Arctic doesn't stay in the Arctic. As the temperature in the Arctic is rising more rapidly than in the rest of the globe, and the temperature on the equator is increasing slowly, the differences between the North Pole and the equator are decreasing. It slows down the global circulation and may affect the weather patterns far beyond the Arctic.